get it through pip install frida-tools typically. There's now a new R2 integration there. Before we get into that, I want to show you just how this tool was typically used in the past. And that was what motivated these new features. So before we do that, we're just going to write a small test program. The idea is that we're going to have a really simple program so we can understand what we're actually looking at. So we're just going to have an infinite loop. We're going to call a function f, and we're going to give it an integer with on each call, and it starts at 1. And we're going to delay 1 second between each call. I'm going to need uni_std_h for sleep, and standard bool for the true constant down there. And we're going to define the function f that we're going to call. So it's given a number n, so it's just going to print that number. And we're also going to print out where f is in memory. You'll see soon why that is useful, but we'll start there. So yeah. So we're going to just run this program, and you can see that the function f is getting called. Yeah, that's it. Now we're going to actually use frida-trace. So we'll do frida-trace hello, which is the name of the process. We could also use a PID, process ID. We're going to do like, we know that printf is getting called, so we can include that. And we know that sleep is getting called, so we'll include that. So we're going to trace those two functions. I'm going to run that inside the demo directory, so it's easier to see what this does, because it's going to produce some files on the file system. So here you can see that we're tracing these two functions. What also happens is that there's a handlers directory generated on the file system, and there's a subdirectory per library that we found functions in that we're going to trace. So here there's libsystem c dilib, and there's like printf and sleep.js, so one generated per function. So now we could go here, and actually this will just generate a boilerplate for us, so we can start like changing the logging or logging what we want. So here you might want to say just change this, for example, to add r2con, and if I save this, it auto reloads, live reloads this hook, so you can see the new output now. So that is useful as a feedback loop for reversing. So here we could also trace the function f. So we could, but then we'd have to start this program over to like add -i, and that's kind of not a great workflow. So that was what motivated this new UI that I'm going to show you. You can also spawn a program like this, -f, and then the path to the binary, and like sleep, printf. So that's another way. But and then if you trace something that's called very early, then you have to run it again. So Control-C arrow. I mean, it's repetitive. That's another part of it that gets boring quick. Yeah, these are the reasons that I decided that we need a UI for this. So if we go back now to the example we have with tracing the hello process, we're including these two functions. with the new version of Frida tools, frida-trace will actually tell you, started tracing 2 functions, web UI available at localhost on this port. So you can open that up, and that is the new web UI. So you can see that they're in sync. Now here, if you actually, I should probably make this a bit larger. So here, if you now click on one of these events here in the log output, you'll see it will actually open the editor here to take you to the code. And here we're using the Monaco editor that VS Code uses, so that means we have code completion. And that means you have inline docs of the whole Frida API, and you'll have type checking and code completion. So that is handy. You can also hover over a variable to see that it has this type. So yeah, now we can, for example, let's close this. Change this hello there and hit deploy, or I can do Command S or Control S depending on the OS. And now I can click this latest event button to go straight to the latest instead of scrolling down the view on the bottom. So this will take me to the latest event from this particular handler that we're editing here. Yeah, and then if we think that this one gets a bit noisy, we can hit the mute button here. And now it's red in the left side here, and we only see sleep now, output from sleep. And we can go and mute that too, and there's going to be no output. And unmute, and yeah, it's going to be back. So, so that means you could do like. Say you want to do, typically in like before the UI, you would want to like know, okay, sleep is called, but where is it called from? Okay, called from, and then insert a backtrace. And then you'll define a backtrace as thread, backtrace this context. Backtrace gives you an array of native pointers, so you can map that to debug symbol from address, and you can join those by new line and tab. And save, and you'll see here that, yeah, you get the call stack. This is tedious to do, so now with this UI, we don't actually have to do this at all. Just remove this, go back to where we were, and I'm going to just toggle capture backtraces here. So now if you look at an old event, you'll see just the caller, but if you go to the latest, you'll see that there's a backtrace. So now we've enabled backtraces just for this function. So you're only paying the performance overhead of it for this particular hook. And now let's look at the R2 integration. So these enters in the backtrace, if you click one of them, it will take you to, we'll use R2. And this is running entirely in the browser. You don't need R2 on your system even. So this means that we're turning Frida users into R2 users overnight just by deploying this new version. And here in this view, like if you have a branch target like here, it becomes a link, so you can click on it to go there. And this integrates with a browser's navigation state, so you can do back here, like you go back to where you were, or forward again. Then say here on this particular instruction, I want to have a hook just here. You can click and do add instruction level hook. And click that, and now we're tracing that too. And it takes, the editor opens here with a handler. That looks a bit different from the other one. If you look here, it has on enter on leave with an object. An instruction level hook has just a function. Now, hopefully we'll have, yeah, go to the latest event. Yeah, here we go. So whenever this function, instruction is hit, this code here is run, and you can do whatever you want. So here, you could do log x0 if you want instead, for example. Go to the latest event. Oh, yeah, and latest. key event, and it didn't update demo effect. It doesn't use, so this is plain JavaScript, but the editor thinks it's TypeScript, so it's a bit confusing. That should be improved. Let's see. Testing, why? Yeah. Oh, SP, I forgot to up. Okay, I need coffee. Let's try. Yeah. So this is X0, yeah. So you get the idea. Now, if if you're looking at this disassembly view and say you have a memory address like here, we have an adder x16 and so on with an address. You can choose between disassembling and viewing the memory. So you can do view memory, and here you have the R2 powered memory viewer, and you can go up and down in memory here or type an address. You can change it to different views, or periscope view, for example. And it integrates with the navigation state as well, so you can go back to where you were. Yeah, and if you were to spawn the process like here, then you'll also see the respawn button. So that means you can just hit this, and you should see that it's respawning the program. And so this means if you have if you're hooking something that's called very early only, then you'll just hit this button instead of the longer restart loop that you had before. Okay, so yeah, going back to the attached state we have here. Oh yeah, and it has a different port number on this run, of course. So another thing you can do, which is actually where the whole thing, this thing started, is I want to add more stuff to trace. So should have started with that actually. But yeah, that's the add UI for that now. And here you can, the UI is not awesome, but yeah, here we go. So you can choose what kind of function you want to add. This would be like, function here would be like -i, and relative function would be -a, and so on. But so like if you switch this one, it will tell you the syntax, like module ! offset. So if you want to hook something where you don't have the a symbol to look it up and export or something, then you can do it relative to a module. But you can also do an absolute address. So that comes handy here when you have the function f. You know where it is in memory. So you can just copy that address and plop it in here and do, yeah, add this. Hopefully, yeah, hello, inson 3 f3c. So we know that this is f, so we can do f hit and go to the latest event. Yeah, here we go. And here we know that the first argument is the n, the integer that's passed to it. So we can do like n equals save and go to the latest event. Yeah, to see the number now. And if we scroll this to the very bottom, you'll see that they're in sync with the terminal output from the hello world program and the event outputs here. So now we have a live trace of this. Yeah, on this. And now, yeah, we can quickly switch between, like, click on events here to go to the handler of each. So if we don't like the output, I can quickly go to the code and change it, change what we're logging, as you're learning more and more about the targets. So say here, You can add Swift stuff. I can do like module function, so you can do like open star, for example. And yeah, this will give you feedback as you're typing, and you can choose to add all of them that matched, or just one of them, for example. Yeah, open PTY, for example. And here it is. So now I think we could take a quick look behind the scenes of how this works, since we still have some time. So that is that is a component called React use r2. Or actually, let's start with the UI. Oops. So yeah, in the frida-tools repo, there's an apps subdirectory which has a tracer subdirectory, and that is a single-page app that's running in the browser. And for example, the memory view, to take that as an example, it imports use r2 from Frida at frida/react use r2, and this gives us an execute r2 command, and then now here we're using the UI toolkit called React. We're setting up basically a side effect here that's going to happen whenever one of these things change. We're going to execute an r2 command, and that's going to be rendered in the UI, the result of that, or the state that it updates. And you can see, like, yeah, this is the HTML that we generate here in the browser. So down here, you can, yeah, we have a div where we have the memory view data, where we output the, where we show the r2 output. And then we use dangerously set inner HTML with the HTML that we got from r2, because we're setting up for HTML output. So it renders, instead of ANSI escape codes, it will have HTML tags. And then we have a bunch of, we have the segmented control to select like what kind of memory view you want, like raw, 64, 32, periscope, and this runs this r2 command, this runs this r2 command, and so on. So whenever this is, one of these is changed, set format is called. Set format just changes that state, the format state. And then this effect here depends on the format. So this effect will run again. So it will then execute the r2 command for that specific format at the address that we are in, that we're showing here. And now, if we go and look at the code of that again, in turn. Yeah, so this whole thing starts with load r2 at the bottom here. Which does load r2 module, and that's a generated function. So we're using the mscript toolchain to produce a WebAssembly binary. This has been done ahead of time. So when cutting a release of this tool, so there's a make file that does this. It builds radare, but uses the mscript toolchain to produce a binary. And then this generates a load, like a function. This module has a default export that just loads the module. And we're calling that, and we're providing it some callbacks that the C code can call back to us. So on the C side, so we're building our R2, and then we have a tiny program that implements an I/O plugin. So here we're just defining the callbacks, And there's a function, exported function called open, r2open. We give it the OS, the architecture, and the bits, and it just sets up the R2 core instance with using that. And then whenever, for example, the open IO plugin handler callback will create a descriptor, close, similar boilerplate. But the interesting part is here, the read callback. So Emscripten has this em-async.js macro that expands, where actually you give it a return type, the name of the function, and the C signature of the arguments parameters. And here the body is JavaScript. And this body here is actually can return a promise or be an async function. So here you can do something asynchronous, and that means we can interface with Frida, with the agent in the far end process. But this is all running in the browser. So here we're doing await module on read. And yeah, that will communicate with the agent. And then just copying that out, the result out. Right, I haven't implemented that yet. That's essentially it. And then on the JavaScript side, it has implemented on read. Down here, too far. Yeah, on read is here. So when we're instantiating this WebAssembly module, calling the function that was generated by Emscripten, the toolchain, we can define arbitrary properties on this object that we give it. And here we're defining onRead, which this IO plugin calls. And yeah, here we have a simple IO cache, because I still need to figure out how to get that working correctly in all cases. So that's temporary complexity. But yeah, here we're calling basically a read, and then the user of this package needs to provide the read. So it's not really tied to Frida at all. You could read from something else. But the feature set that Radar was built with is tied to Frida. That's why it's in the Frida namespace on NPM where this is published. So I didn't want this to look like something to be used for all use cases, but because we're building R2 with exactly the plugins that Frida needs, so we're limited to the architectures that Frida supports. And that means we have a fairly small footprint. So, for example, PyPy. I can just download Frida tools from PyPy, I guess. Yeah, so it's a 4.6 megabyte download. Oops. Frida tools. Oh wait, so inside the Frida tools package from PyPy, you can see that there's the tracer, which we're running here, frida-trace, and then there's the agent, which is injected into the remote process, and then there's a tracer UI, which is the browser part that's running in the browser. And if we extract the UI, you'll see here in assets that there's R2 WASM here. So all of R2 that is running in the browser is only 8.7 megabytes, which is pretty good, considering that it supports all the architectures Frida supports and has capstone and so on. But yeah, that's basically how the IO plugin works. This UI is still in the early stages of development, but hopefully, so it doesn't have export, for example, and doesn't have a way to load, let's say. So yeah, lots of areas for future improvement, and the UI has quite a few rough edges, but Just wanted to show you, so hopefully some of you might contribute to it to make it better or work for your use case. And yeah, any questions? All right, thank you.